Walang nakakaalala? Yes po, Mr. Barola.
Natapos po yung for na problem solving ng face-to-face, saka po yung mga series generator po, yung apat ga po, yun po.
Ayun.
Yun pong may drawing.
Okay, thank you for that info. So, natapos natin hanggang different types of generator. Okay, so, ibig sabihin, magsa-start na tayo ngayon ng problem solving. Okay, so, before that, attendance tayo. Adonai,
Nasaan po?
Aguila, Aguilar,
Present po.
Alcantara,
Present po.
Alvarez. So, alin ang wala? Ilan? 1, 2, 3, 4, 5, 6. Oh, ba't naging 6 ang wala? Okay po. Nandyan pala si Miss Morito. Ano? Okay, so sige, start na tayo. Paano tong mga wala na to? Yung mga kaibigan nyo dyan, kung kaibigan nyo yung mga wala today, so kayo ang magtuturo sa kanila. Ano? Kayo magtuturo. Yun naman na yung advantage. Ano yung ikaw ang magtuturo. Matatandaan mo kung ano yung mga tinuro mo sa kanya. Okay, so again, tatapusin na natin ngayon ang DC generator. Pagka po bigla na lang ako nawala, bigla na lang nag-out ang aking account dito, that means walang internet. So, pakichat na lang ako ha sa GC. Wait lang. So, tayo ay solving ng different types of generator. Alam. Okay, nakikita na po ba ito?
Opo.
Okay, sige, start na tayo. A 200 kilowatts, 230 volts pound generator is connected in long shunt. If the shunt field resistance is 30 ohms, what is the series field current? Okay, so first is alamin. You have to know what type of generator is in the problem and also what are the given parameters. Okay? So, sabi ko nga last time, di ba, na if there is a power and a voltage given, which is the rating of the generator, that is your PO and VP. PO or output power and terminal voltage. Okay? If there is a rating given, that is your output power and terminal voltage. Then we have a shunt field resistance. So shunt field, that is RSH. So this one, 30 ohms. Ano daw ang series field current? Yan ang unknown. Okay. So after getting all the given, you have to draw the circuit. Okay? So sabi, long shunt compound generator. So this is the circuit for a long shunt generator. So we have here PG, RA, RSE, RSH, and VT, or the load. Okay. So if the unknown parameter is series field current, then we will get the equation. Okay, so if it is current, so we will do a KCL, Kirchhoff's current law. Ano? So, magki-KCL kayo here at node A. So, KCL at node A. So, that will be IA is equal to ISE, right? Because they are in series. So, IA is equals to ISE. So, that will be IA entering the node, that's why it's positive. Then ISH is leaving the node, that's why it's negative. And the IL is also leaving the node. So that's why it's I or minus IL equal to 0. Then, equate nyo siya. Equate this equation to IA, and that will be IA equals to ISH plus IL. And IA is equal to ISC. Ayan. Then, we have to get ISH and IL. Where can we get that? So, ISH is equals to, so as you can see, the terminal voltage is equal to the voltage drop across RSH because they are in parallel. So, we will get that VT divided by RSH. Bakit po ganyan? Because current is equals to V over R, right? So, to get the current here, we will use VT divided by RSH, wherein VT is 230 volts and RSH is 30. Plus IL naman, you can use this formula, which is PO over VT, right? Because PO is equals to VT IL. Ano? Last week diniscuss ko na yan sa inyo. Ano? So we have PO 200,000 watts divided by 230 volts. Then input that in your calculator. Then we will get an IA, which is 877.2319 ampere, wherein IA is equals to ISE. That's why this is our final answer. Okay. Again, what do you need? What what do you need when you're gonna show me your solution? First is the given. Second is the circuit. Then third is the computation or yung full solution na. Then your final answer should be inside the box. Okay, when there is no box, wala kayong sagot. Okay, no points, no answer. Pagka walang box. Okay? So, yun pong mga problems, wala po yung circuit. You're the one to draw the circuit. Okay? Any question regarding to this?
None po, ma'am.
Wala po,
None?
ma'am.
Okay. Next. Okay, so a long shunt compound generator has a shunt field with 1,200 turns per pole and a series field with 4.5 turns per pole. If the shunt and series field ampere turn are 1,200 and 196 respectively, calculate the power delivered to the load when the terminal voltage is 220 volts. Okay. So, first is get all the given parameters. So, we have a shunt field 1,200 turns. When it is in terms of turns, that is N, right? Number of turns. So that is NSH. Bakit SH? Shunt field daw. So NSH, which is 1,200 turns. And a series field, 4.5 turns per pole. So N for the number of turns, and SE, which is series field, which is 4.5 turns daw. Then, if the shunt and series field ampere turns are 1,200 and 196 respectively. So we have here 1,200 ampere turns
lang yun ha, si PO at si PL. That's why it's VTIL. Okay. So, meron tayong VT, wala tayong IL. So, we have to get IL. Where can we get IL? So, this problem is more on unit analysis. Okay, so unit analysis. So, as you can see, this is in ampere turns. This means this is current times number of turns, right? I times N. I times N. So, we have to get the current. So, this one. So, what do you need to do? You have to divide it by number of turns so that we can get the ampere or current. So, to get ISH, we have here NSH over, no, 80 SH over NSH or 1,200 ampere turns divided by 1,200 turns so that we can uh, cancel this unit which is turns. So, ano na lang matitira? Ampere. That's why it's already current. So, 1,200 ampere divided by 1,200 is 1 ampere. Okay? Then for ISE, we have 196 ampere turn divided by 4.5 turns. Cancels the number of turns. That we will get 43.56 ampere. Now that we have ISH and ISE, we can now get IL. Okay. So, ano ba yung itsura ng ating generator? Sabi ay long shunt. So, you have to draw it first. Dapat ito yung una pa lang pala na i-drawing nyo na ha. Okay. So, kung makikita ninyo, si IA dito ay equal kay ISE. Diba? So, this means IA is equals to ISH plus IL. And to get IL, lipat mo lang to sa kabila. That will be IL is equals to IA minus ISH, wherein IA is equal to ISE. So that it will be ISE minus ISH is equals to 43.56 minus 1 and IL is equals to 42.56 ampere. Now that we have IL, we can now get PL or the output power or the power delivered to the load. So we have 220 volts, which is the terminal voltage, times 42.56, and your PL is 9.3622 kilowatts or simply uh, 9,362.2 watts. Ayan. So, maalin dyan is correct. Okay. Do you have any question? So, minsan, merong mga problems na yung given is nakakapagtaka. Ano? Sabihin niyo, what is this for? Ano ba yung formula na may ganito? Ano? Wala na, parang wala naman kaming na ano na ganun. So, ang gagawin nyo ay unit analysis. Kung ano yung kinakailangan, yun dapat yung matira na unit. Okay. So, do you have any question?
Wala pa naman po.
Okay. So, next tayo. So, parang ano na din to. Parang kagaya lang din nung last time. Ano yung EG is equals to flux per pole, PNJ over 60A. Okay? So, a 10-pole simplex wave DC generator has 3 coil per slot, 3 turns per coil, and 161 number of slots. Flux per pole niya is 1.5 times 10 raised to 6 lines, and the speed is 1,500 RPM. Find the generated EMF.
Ang ating demand factor siya ay ating ratio ng ating maximum demand.
Okay, so alam niyo naman na kung paano kuhanin to. Diba? Ah, wait. Na
So
ano
ano
ko
ba
ba
ang
sa inyo
ating
yung
maximum
conversion.
demand on this given
Ito.
on this given
So please
problem?
include this in your index card. Ano? Ito yung mga conversion factor na kakailanganin nyo to get conductors. So we have two conductors per turn. We have one element, one conductor. One coil is equals to two elements. We have number of coil or number of elements per coil is equals to one half number of slots. Then one conductor per layer is equals to one coil per slot. So let's try to have an example regarding to this conversion. Ayan.
0.4651
So,
daw.
ito yung mga given natin. Ano? Given
0.4621
parameters.
daw.
Then,
Tama ba yan? Okay, let's try
what is the formula in getting the generated EMF? We have flux per pole, P and Z over 60 times A
20
times
divided
10
by
raised to negative 8. Why? Because our flux per pole
0.4651.
is in terms of lines. That's why,
Oo,
okay?
meron tayo.
So,
46.21 demand.
look at your formula. Then, let's see if
Next one na natin,
everything is
calculate yung ating
present. Ano?
load factor.
So, we have
Ang
flux
ating
per
formula ng
pole.
ating load factor.
Meron. We have number of
So, we have a
poles.
formula,
Yes, there
which
is.
ang ating
We have
average
N,
load
which is the
natin.
speed. And do we have Z? Wala pa. So, we have to get Z or number of conductors.
May given ba tayong
So,
average load dito sa given natin
we
problem?
have, let's say, 3 coils per
Wala,
slot
di ba? So, paano natin makuha si
times,
average load?
we have 161 slot
Meron tayong given na units
times,
generated.
we have to
1.5
remove,
times 10.
kung tanggal to, we have to remove coils
So, pwede
then.
natin siya
So, we
gamitin.
have 3
Iwanan muna natin yung
turns
ating average value.
per
Itong
coil.
ating
So, cancel tong
generate for the
coils.
whole year.
But
So, for
there
the whole
is,
year, yung ating hours, so divided
there's
natin
still
by 7 hours,
turns.
10
We
hours.
have to remove
So, 5
turns.
hours.
So, we have to get the conversion. So, we
Units
have a
generated per
conversion of 2 conductors per turn.
per annum divided by our maximum demand.
So, we have to
Maximum
cancel
demand
turn, and then we
multiplied by
have
our
here now the
number of
conductors
hours,
or
which is
number of conductors.
2,760
So we have 3 times 161 times 3 times 2. What is
ano,
the number of
units
conductors?
generated per annum. Meron tayo 61.5 times 10 raised to 6. Ano ang unit ng ating units generated per annum? Ano ang unit ng ating 61.5 times 10 raised to 6? Wala tayong given na unit. So ano ang ating gagamitin siya? Na value. Na unit para sa
2,898 po.
2,898 conductors. Okay, so that is our Z. So meron na tayo din. How about A? Sabi ko, A is equals to wave. Wave ang winding. That's why it's 2 times M. And sabi ay simplex. When it is simplex, your M is equals to 1. So this one will be 2 times 1 and your A is 2.
Shopee po siya.
So we have A.
Yes,
Okay, so substitute everything in your formula. So we have flux per pole.
Shopee pa rin ba ang sir?
P and Z natin is 2,898 conductors and 60 times 2 times 10 raised to negative 8. So what is our generated voltage? So we have
So, ano ang ating unit?
5,433.75.
Ano daw ang unit ng ating generated?
So is that
Per
correct?
annum dito sa ating given example. Any idea? Any guess?
Is that correct? Please use your calculator, ha? Because I don't have calculator with me.
What are? Ano what are siya? What are lang ba? O kilowatt hour o megawatt hour? Ang ating gagawin.
Tanggalin nyo na to.
Sabi ni Brian,
Ang
ay
gamitin nyo na
watt hour.
yung 2,898.
Megawatt. So, balik tayo dun sa ating discussion. Yung ating unit generated per annum.
Hello, nandyan pa ba kayo?
Ma'am, team naman po ang sagot ko.
Yes po.
Ating unit generated per
Okay,
annum
so,
ay average
okay,
load
thank
in
you
kilowatts.
po. So that is for number 7. How about number 8?
So a 4-pole DC generator with lap winding has a 48 slots and 4 elements per slot. How many coils does it have? Okay, so first is we have 4 elements per slot. Multiply natin kay 48 number of slots so that it can cancel out. But, uh, wala namang given na ganito, di ba? This is one of the conversions I flashed kanina. So we have one coil per 2 elements. So we have to cancel elements. Okay, so nasan ba siya? Ito one coil equal to 2 elements. So that means one coil per or one half coil per element. Okay? So now that we have coil, makakuha na natin yung hinahanap. So we have 4 times 48 times 1 half, which is 96 coils. Naintindihan? So, again, yung mga conversion factors, kanina naka-flash dyan is very important. So you have to familiarize with that. Next, the armature of a 4-pole shunt generator is lap wound and generated 216 volts when running at 600 RPM. The armature has 144 slots with 6 conductors per slot. If this armature is rewound, wave connected, find EMF generated at same speed and flux per pole. So, this problem has two conditions. Okay, the first condition says that it is lap wounded or lap winding. Then the second condition, it says that it is rewounded and it is now wave connected. So from lap, naging wave na siya. So what does it mean? Anong nagbago? Anong nagbago? Nagbago ang kanyang from lap, naging wave. Anong nagbago? Diba yung number of parallel pa? Diba ang A ni lap is P times M and A ni wave is 2 times M, right? So si A po ang nagbago. Okay, so we have A1 and A2. So in the first condition, sabi, nakalap wounded siya or lap winding. And then wala namang sinabi kung ano yung number of multiplicity niya. So, let's say it's 1. Pag walang sinabi, the number of multiplicity, that is 1. So, A1 is P times M, that means 4 times 1, and A1 is equals to 4. Then for A2, we have 2 times 1, that means that is 2. Okay. So, basically, if you have two conditions, the first condition is used to get a parameter that is missing to use for the second condition. Okay? Kasi ang sabi dito, find the generated E and F when it still have the same speed and same flux per pole. Okay? So, same pa rin lahat ng parameters. Ang nagbago lang is yung kanyang connection. So, what are we going to do? So, we have EG is equals to flux per pole, P and Z over 68. Okay. So, we have EG. EG is given. Do we have flux per pole? None. Diba? So, that's what are we going to get? Ano, si flux natin. Because we need that. Kasi sabi nga, same speed. Same speed and same flux per pole. That's why we need to get the flux per pole. But here, in this case, you can get the total flux naman. You can get the total flux na lang. Ano? So that's why it's total flux times N and Z divided by 60 times 8. So substitute everything. So we have 216
equals to flux total times 600, which is your RPM, and then 6 times 144, what is that? That is your number
Yan
of
ang natin gusto na
conductors.
gagawin dito.
Because
May
we have
maximum
6
naman ba tayong
conductors
given?
per turn,
May
per
maximum
slots
naman ba
pala,
tayong given?
per slot, multiply nyo ng 144 slot so that we can
May
cancel it
average load
out.
ba tayong
Then we
given?
have the Z, which is 6 times
Any
144.
idea? May maximum or average load ba
Okay,
tayong
so this
given?
is your number of conductors. Okay,
So may
so
nabanggit pa doon
with
sa
this,
binasa ni Nicole kanina.
the flux total is equals
May
to
nabanggit pa, this is
0.1
our
Weber.
maximum demand.
Why
This
is it
our
in terms
average
of
load.
Weber? Because we don't have times 10 raised to negative 8 here, right? If you have times 10 raised to negative 8 here, then your answer will be in Maxwell or lines. Okay? So now that we have the total flux, we can now move to the second condition. Okay, in the second condition, it says that what is the generated EMF? When it is rewounded, wave connected naman. Okay, so we have a
Ano,
change
meron ba
in
tayong average load na
number of
given? Wala,
parallel
di ba?
path.
May
So we have
maximum
here
demand. May given ba
0.1,
tayong
which is the
maximum
total
demand dyan?
flux from the
May
first
sa akin
condition.
matuturo.
We have the same
Wala po ata sa
speed,
maximum
which is
demand. Wala
n.
din tayong maximum
Then we have
demand.
the same number of conductors divided by 60 times 2. Why is it 2 now? Because it is wave connected na. So your A is 2. That's why we can get now the second generated EMF, which is 432 volts.
Meron ba tayong maximum demand
So
sa
as
ating
you can
given?
see from the first
Bigyan mo muna
condition,
yung ML.
the generated
Wala
voltage is
nabanggit. Pero any idea kung
216
meron ba
only
tayong
when it is
given?
lap wounded. Okay? But when it is winding now or wave wounded, it is now
Ito na
double.
siya na si...
It doubles, right?
Yan.
From
Sabi ni Steve,
216,
kasi
it became
100 megawatt. Bakit mo nasabi
432
Steve na 100
volts.
megawatt sa sabi?
So this means
Maximum
when
demand.
it is wave winding, it has a bigger generated EMF.
Paano mo nasabi?
Okay? So, do you have any question?
Yun po yung dinilito. Yes, very good. Tama si.
Wala po, ma'am.
Kasi may nabanggit dito na nakapag-deliver in a day na may 100 megawatts.
Okay, next
Meron tayo
example.
50 megawatts. So, based naman dito sa ating binigay na loads,
Okay, so a 5 kilowatts, 120 volts compound generator has an armature resistance of 0.25 ohm, a series field resistance of 0.05 ohm, and shunt field resistance of 60 ohm. Assume that the voltage drop at the brushes of 2 volts and determine the power generated. Power generated ang hinihingi, that is PG. Okay, so first you have to draw the circuit. So sabi ay compound generator. What kind of compound generator? We have long shunt and short shunt. Okay, so
Long.
yes, it is automatic long shunt generator. Okay, pag sinabing compound generator lang, that is automatic long shunt generator. Okay, so we have here a long shunt generator circuit. So we have here EG, RA, RSE, RSH, and yung load natin. And we have here the VT, which is the voltage across the load.
wala lang, sir. Inform niyo ako kapag ako yung nag-test.
Okay, so we have to get all the given parameters. So we have here a rating of 5,000 watts and 120 volts. That means that is your PO and VT. PO is 5,000 watts. VT is 120 volts. Then we have armature resistance of 0.25 ohms. We have a series field resistance of 0.05 ohms. Shunt field resistance or RSH, which is 60 ohm. And we have a voltage drop at the brushes. So that is VBC, which is 2 volts. When we say voltage drop at the brushes, that is VBC. Okay. And where is the brushes located? Brushes located is located at the near the
Ano ang
armature.
ating total
Okay,
duration?
near the armature. Okay, si brushes po ay nasa katabi ng armature. Okay?
100 times 2, meron tayong 200.
Okay, so to get
500
PG,
times 6, meron tayo.
anong
250
kailangan
times 2,
natin?
meron tayo.
EG and IA. Do we have EG? Wala. Do we have IA? Wala. So we
200
have to
times
get them.
500.
Okay, so what do you think is
I-multiply na lang ba natin siya sa ating ah 365 days para makuha natin yung value.
what do you think is gonna
Meron
be the
tayong 500
first
megawatt hour per day.
first honor?
I-multiply ba natin siya sa
Okay,
365
so
days
yung
para
first
makuha natin
natin
yung value?
kukuhanin is IA because to get EG, we need IA. To get
Kasi,
EG, we need IA,
nakalagay dito
right?
sa
So we have to
problem,
get
sinot down
RA
natin yung
first.
information ng
And then to
system.
get IA, mag-KCL kayo kay node A. KCL at
Ibig
node
sabihin,
A.
ilang days lang siya? Bali,
So
i-multiply
that
natin
will
siya
be
sa 365
IA
days yung ating
minus ISH minus IL equal to 0, where IA is equals to ISE, right? So that will be IA is equals to ISH plus IL. Where to get
Paano
ISH and
makukuha natin
IL?
ang
ISH is equivalent to
1
VT over
megawatt hour?
RSH and
ISC,
IL is equals to
units ng
PO
ating
over VT.
annual energy.
Okay? So we have now VT which is 120, RSH natin is 60, and PO 5,000, VT is 120. So ang ating IA which is equals to ISE ay 43.67 ampere. So now that we have IA, we can now move to EG. So from this circuit, EG minus IARA plus RSE. Why? Because they are in series. Minus VT. From here, papunta na dito si VT. Then you will, ang tawag dito, you will include the voltage drop at the brushes. So you will minus it here, minus VBC equal to 0. Okay, so we have to equate it to EG because that is the unknown parameter. So we have EG, lipat nyo lahat sa kabilang side. That will be IA times RA plus RSE plus VT plus VBC. Okay, you will include the voltage drop at the brushes always. Okay? If there is given VBC. But if there's not, but if there's But if VVC is not given, then don't, okay? So, your IA is 43.67 times 0.25 plus 0.05 plus 120 volts, which is your VT, and your VBC is 2 volts. Then, EG is equals to 135.1 volts. Okay, so we have now EG and IA. We can now get PG. PG is equals to EG times IA. That is 135.1 times 43.67. And the generated power is equals to 5,899.37 watts. Okay. So, tatandaan nyo lagi na ang IA natin ang pinakamalaking current. Okay? Pinakamalaking current yan. And then, si EG, mas malaki po yan lagi kay terminal voltage. Kasi siya yung generated voltage eh. Diba ito si generated voltage? Bago niya pa mailabas yung voltage na yon, naging VT na lang siya. Bakit? Because of the losses. Ano yung mga voltage drop sa mga resistances. Okay? So, yan. And then, PG is greater than PO because that is, PG is in input side and PO is in output side. So, bago pa mailabas ang PO, si PG nabawasan nang nabawasan ng mga losses. Okay? So, tingnan ninyo, ang ating PG, 5,899. Ang PO, 5,000 na lang. Okay? So, always Tandaan nyo ha. Ayan.
Divided
Lang.
by maximum demand
So, do you have any question?
multiply by
Wala namang problema
Nalo.
dito. Wala namang problema dito sa pagkuha ng equation. Ano, basta alam ninyo. Kumbaga, ito naman A from B.
ano ang ating
Kaya alam na
value
ninyo.
for 60,000?
Then, kapag marunong kayo mag-conceptualize ng isang circuit, then you can get the equation. Kahit hindi nyo siya sa uluhin, you can get the correct equation if you know the concept of the
Divided by
circuit.
maximum demand natin, ano maximum demand natin?
Okay, so
100 megawatt.
next ay power stages na tayo.
320 times 24, meron tayo.
So si power stages po, siya yung dito natin makukuha yung efficiency ng isang generator. Okay?
Ano ang ating magiging value? Magaling nyo sa calculator, paki-input. Para masala yung mga sandiri kung paano mag-solve yung mga problem sa power plant. Meron tayo 0.20.
Okay.
0.20. Or meron tayo
So power stages. So, di ba, kay generator, merong input, merong output, and then generated.
ay wala mga computation.
Okay, so ito yung ating concept ng power stages ng generator. So, we have the input power, we have the generated power, and then we have the output power. Okay, and then we have here the mechanical losses, which is, say for example, we have the friction and windage loss, we also have the core loss, no, we have the iron loss pala. Iron loss, and we also have the forward loss. And it is also called stray power losses. O, ito na yon, ML, mechanical loss, or SPL is equals to friction and windage loss plus iron loss plus forward loss. Yeah. So we have here friction and windage. We have here iron loss and forward.
While running as per schedule work, ano ang ating formula ng ating reserve capacity?
Ayan. So, from the input power, diba, ito po yung part ng mechanical. Diba, mechanical to electrical sa generator. So, ito yung mechanical part. That's why we have yung mechanical losses. And then here we have the electrical part. Okay? So, from mechanical to electrical energy. So, dito sa electrical part naman, we have the copper losses or PCU.
May plant capacity ba tayong given dito sa
So, ito po yung mga losses which includes resistances. That's why it's PCU equals to IA squared RA plus VT squared RSH. So, as you can see, ayan. So, included sa kanya ang ito yung mga power losses that includes resistances. Si ma'am inaantok na. Ihadong kayo din. So, gising-gising muna ha.
Meron tayo.
Pagka busog talaga, nakakaantok. Okay, so, ayan. So, from PN, nagkaroon ng mechanical losses. That means nabawasan yung ating generated power. Then, nabawasan ulit bago pa siya maging output power. Okay, so to get PG, that is EG times IA.
Madali lang yan.
And to get PO, we have VT times IL. Paano naman kaya kuhanin yung input power? Ito. Okay, so to get the input power, we have here PG plus SPL or mga mechanical losses. And PG naman is equivalent to PO plus copper losses. Okay, so, and then we also have PN, which is equivalent to PO plus total losses. What are the total losses? We have here the variable loss, and constant loss. Okay, so that will be Pn is equals to PO plus VL plus CL. Okay, and your VL or variable loss is IA squared RA, and your constant loss is VT squared over RSH plus SPL. Pagka po sinubstitute nyo na yan dito, dalawang ito, magiging PO is equals, PN is equals to PO plus IA squared RA plus VT squared over RSH plus SPL. This is the most important formula for PN. Okay? So, ang PN po or input power ay nagbabago. Yung formula na yan ay nagbabago and it depends on what type of generator you have. Okay? So, PN varies depende sa inyong type of generator. Okay? So, next we have the efficiency. First, we have the overall efficiency. Okay, so overall efficiency is equals to PO over PN times 100. Okay, PO over PN, overall efficiency. Then we have the mechanical efficiency. Where is the mechanical part? This one. So that means your mechanical efficiency is PG over PN. Okay. Then for electrical part, sa electrical part naman po natin ay saan galing? Nasaan ba siya? Ito. So PO over PG. Okay. Then we also have this formula for overall efficiency. Percent or mechanical efficiency times electrical efficiency is equals to overall efficiency. Paano po nangyari yon? So, si mechanical po ay PG over PN. Si electrical po ay PO over PG. So, if you multiply these two, cancel to cancel, then this will be PO over PN, wherein it is equals to the overall efficiency. Understand? Hello, do you understand?
Yes po, ma'am.
Yes
Ah,
po.
okay, so now let's move to the input power or different input power in different types of generator. Okay, so what is this generator? Anong generator to? Pinakauna. Anong generator yan?
Shunt
Short.
generator.
Shunt generator. Okay. So, kapag ka daw shunt generator, so alin ba yung, ano yung pinaka-general formula ni input power? PO plus IA squared RA plus VT squared over RSH plus SPL, di ba? Yan yung pinaka-general formula. So, ano itong mga additional na to? Okay. So, we have here PO plus IA squared RA. So, IA squared RA because here, di ba ito yon? IA squared RA. Meron pa bang any other resistances aside from RA? Di ba wala na? Okay, so ano tong RBC na to? Si RBC is what you call brush contact resistance. So if it is given, then you will put it and add it to your RA or armature resistances because nasan ba si brush? Brush is near the armature. Okay, it is in series with the armature. So if you will put RBC here, it will be here or anywhere in series with RA. Let's say it's here. Ano? If there is a brush contact resistance, it is in series with RA or the armature. That's why it's here. You will just add it. Okay? Then, next power is the power here.
Sir, walang
in your RSH. To get the power there, what is the voltage across RSH? That is VT. VT because it is in parallel with RSH. That's why they are equal in voltage. So we will use that
times
as its voltage, which is VT squared over RSH
24.
plus SPL plus
Yung
IA
average load
times
equal siya sa
VBC.
ating
What is VBC? VBC is the voltage drop, voltage drop
factor
at the
times
brushes.
ano ating
Okay,
maximum
so
ano natin
if the
pinipili sa
voltage drop at the brushes is given, you will include it also. And you will
60% times
uh,
6 times 24.
multiply it by IA because
Anong
as
ating
I
magiging
said,
energy produce?
brushes
O sa
is
current
in
drop.
series with armature. Okay? Katabi siya ni armature lagi, si brushes.
4%.
Okay? So, if it is given, then include it. If it is not, then uh, just, ang tawag dun?
What will be our daily
Neglect.
energy?
If it is not given, then neglect it. Okay? So, that is for a shunt generator. How about in short shunt? Short
Yes, very good. Meron tayong
generator.
360
Short shunt
megawatt
generator. So, how to
or
get the
meron
input
tayong
power here?
yung kilowatt hour natin is
Okay, so we
4.
have here
We
PO,
will
as
the energy
always,
produced in kilowatt hour.
plus
Then
IA
simplify
squared
naman
RA
natin
plus RBC. So, as you
times
can
10
see,
to the kilowatt
there
hour.
is no other
Then we will
resistance here,
simplify
only
by
RA.
kilowatt.
Then you will multiply it
Sana
by
all
IA
kasi ating
squared
maging masaya sa
plus
trabaho natin.
RBC if the brush contact resistance is given. If it is not, then neglect.
Then the last
Okay.
one, yung ating maximum energy that could be produced daily
Then we
is
have
1.5
here, after this, we have here this one naman, power
Paano naman yun?
here in RSE.
Ano
So
natin
what
makuha
is
yung
the
maximum energy?
current flowing across RSE? That is ISE,
Pwede
wherein
mo
it
lang
is equals to
i-suppose yung
IL. That's why it's IL squared RSE. Next, we have this
plus
um,
this factor.
resistance naman. We have Vx
Since
squared
nagamit
over
na natin yung
RSH.
tatlong unang
Why
mga
is
given,
it
so
Vx, not
ano
VT?
to,
Vx
very
because
nakaka
the terminal voltage is not equal
napaka-agad ng energy
anymore
produce.
with the voltage here in RSH or the
Depende
voltage drop
naman yan.
here
Baka naman
because
plus this factor ang
there
ating
is
i-suppose.
a resistance here.
Ano ba ang formula ulit
No,
natin
they
sa
are not
VSD?
parallel
Tingnan
anymore.
natin kung pwede
So,
natin
you
siya
have to get the equivalent voltage.
plus this
So,
factor
I
natin is equal
already
sa ating
explained that to you, di
scheduled
ba?
output
How to get the Vx.
divided by
So,
our
hinila ko lang po,
maximum
pinagtabi
energy
ko lang si RSE at
that will
load.
be produced
Then,
sa daily.
across the load, we have here terminal voltage
May
and
given
the
tayong
current
40 stack or
flowing
meron tayong
through
scheduled output.
RSE is IL. Then we have here the
Meron tayong
RSH.
nakuha daily energy.
Then let's
Kundi na
say the
lang,
voltage across RSH is now Vx. And to get Vx, you just add RSE or the voltage across RSE and the terminal voltage, and that will be Vt plus IL
ito yung
times
scheduled output.
RSE. Okay,
So,
so
pwede
this
natin makuha
one
si ating
is this one.
maximum energy
Okay,
na pwede
plus
natin i-produce
SPL
daily.
and
Sabi
plus
natin na
IA
maximum energy
VBC. Again,
that
this
could
is
be produced
only
daily. So, ito
if
ang
it
daily
is
maximum.
given.
Daily
You will
maximum.
include this if it is given, the voltage drop at the
So,
brushes.
meron tayong daily
Then if
scheduled
not,
output. Dalawa
again,
daily scheduled
neglect
output
it.
natin. Kung alin yung ating mag-generate for
Okay.
that
So,
specific output.
siguro nagtataka
Is
kayo,
meron tayong
bakit may current,
360
may voltage, may ano? Ay,
megawatt.
di ba sabi ay power. Summation of
So, paano
all
natin
the
makuha si maximum
powers.
energy?
Okay.
So,
So,
i-divide na natin siya sa
di
ating
ba si power,
plant use
we
factor.
have a
Ano ang
formula
plant
for
use
power
factor
which is
natin?
current times
X L.
voltage.
Galing siya
We
sa
also
formula.
have I
Ano yung
squared
ating
o
magiging
I squared times R.
energy?
And we also have V squared over R, right? So, lahat yan ay formula ng power and this is a power. Power and power. Okay, so they are all
Ano
in
ang ating
terms of
magiging value dyan?
watts. Okay? So, yeah, that is for shunt generator. How about
Try nyo sa output.
in long shunt? long shunt generator, to get the input power, we have PO, as always, plus IA squared RA plus RSE plus RBC. Why is it RA and RSE? Because from RA, or aside from RA, we have here a series field current resistance wherein it is in series with the armature resistance. That's why we have to add it here. Then if there is a brush contact resistance that is given, just include it here because again, brush or brushes is always in series with armature. Okay? Then we have VT squared over RSH. Saan yun galing? Dito. Bakit po VT na ulit siya? Why is it VT again? Because the terminal voltage here is equals to the voltage across RSH because they are in parallel. Plus SPL plus IAVBC. Again, IAVBC will be included if there is a VBC given. If there is not, then neglect it. Okay. Whew. Diyos ko, nauubos ang aking English. Sana naintindihan nyo. Okay, so any question regarding to input power in different types of generator?
Wala naman po.
Okay. So, dito na tayo kay problem solving. Wait lang po ha. Okay, so nakita niyo ba yung in-upload ko na examples? Yung mga example problems. So, ito din po yun. Isosolve ko siya ngayon. Then, please try to solve it on your own after our discussion. Okay? So, nandito lahat ng mga final answer. Then, palalabasin nyo na lang kung kaya or kung may naintindihan. Okay, so example number 1, long shunt compound generator delivers 100 ampere at 240 volts. The RA is 0.0325 ohm, the RSE is 0.03 ohm, and RSH is 60 ohm. The iron loss is 1,200 watts, and friction and windage loss is 500 watts. Calculate the overall efficiency. Okay, so first, you have to draw the circuit. Then, ilagay lahat ng given. Then, what is the unknown parameter? Or what is the unknown? So, we have here, long shunt compound generator. So, this is the circuit. And then, we have here the given parameters. So, sabi, generator delivers. What does it mean when it say delivers? Delivers is, that means nasa output part na siya ng generator, wherein, ano ba yung nasa output part ng generator? So, we have here the VT and IL, right? So, that means this current is IL and this is your terminal voltage. Okay? Then, we have 0.032 or 325 ohms RA. Then we have RSE, RSH. We have the iron loss or PC, 1,200 watts. Then friction and windage loss na 500 watts. Okay. So, anong hinahanap? Overall efficiency. What is the formula in getting the overall efficiency? We have PO over PN times 100. So, we have to get PO and we have to get PN. So, let's start with output power because it is very tawag dito, pinakamadali na kuhanin. Ano? Because that is from VT and IL. And that is given already. So we have VT times IL, which is 240 times 100. Our PO is 24,000 watts. Okay. Next is yung input power naman. So to get the input power, ilagay niyo muna ang formula. Okay. So from the long shunt circuit, so we have here PO plus IA squared RA plus RSE, right? Because they are in series. So you have to include that. Then next is VT squared over RSA plus SPL. So that's all. Ano, that's it for a long shunt input power. So we have PO. Do we have IA? Wala pa. So we have to get that. We have RA, RSE. We have VT, RSH, and we can now get SPL. Diba? So to get IA, so you have to get the equation. So always naman na ganito yung equation ni IA, diba? IA is equal to ISH plus IL. Okay? So si IA equal na siya kay ISE, ha? Equal na siya kay ISE. So si ISH, that is VT over RSH. And IL is from PO over VT. So VT is 240 divided by 60 ohms plus PO na 24,000 divided by 240. And that means your IA is equal to 100 plus 4, 104 ampere. Okay, so this is our armature current. So now that we have that, ano pang natin? Si SPL. Diba sabi ko kanina, si SPL or mechanical losses ay friction and windage loss plus PC or iron loss plus forward loss. So kung ang binigay lang ay PC at friction and windage loss, then neglect this. Ano, hayaan mo na siya kung wala siya, okay? So, pag-add nyo na lang si PC at FWL. So, that is your SPL. Okay, so, substitute all the parameters. So, we have 24,000 plus 104 squared times RA plus RSE plus 240 squared over 60 plus yung SPL natin na 1,200 plus 500. Then, paki-input sa calculator ninyo and let's see if the input power is 27,336.
Yes, very good. Meron tayong 1.12. So, hindi po siya kilowatt, ano. Kasi makakancel natin yung ating mga kilowatt dito. So, unitless po ang ating mga factors sa ating variable sa power. Kaya meron tayo 1.12 diversity factor. Ang ating diversity factor ay always greater than 1. Please make sure na tanda natin yung ating kumpay na.
Hello, tama ba?
Since meron na tayo 4 kilowatts sa taas, makakancel na natin.
Hello? Diyan pa ba kayo?
Opo, same lang po.
Okay, so our overall efficiency is 24,000 watts divided by 27,336 times 100, and that is 87.80%. So that is your efficiency. Okay, so okay pa yung generator na yan pagka ganyan yung efficiency niya. Ano? Huwag lang bababa ng 60 yan, bababa. Sira na yun, papunta na sa sira yun. Masyado nang mababa ang output. Okay, do you have any question? Okay, so if none, let's move to number 2. Okay, so ito naman si number 2. So, yung kanina ay long shunt generator. Ito naman ay shunt generator.
So, shunt generator,
Wala ano.
may
Pero wala
tsura,
tayong given na
draw the
annual
circuit.
generated niya. Annual unit generated. Na meron tayong 45 times 10 raised to 5. Anong unit ito? Kilowatt. Nabanggit kami dito na number of kilowatt hour generated per year is 45 times 10 raised to 5. Kaya yan ay kilowatt. Ano naman tayong energy generated
Okay.
or unit generated?
So, a shunt generator delivers 195 ampere at terminal voltage of 250 volts. Nagiging robot na.
Divided by maximum demand multiplied by ano, 876.
Papagod na yung lalamunan ko. Nagiging robot na eh.
78
Ano ba yan?
Kasi siya ay year. May year basis tayo.
Okay. The armature resistance, shunt field resistance. Wait lang ha. Pwede break muna tayo ng ano. Wait lang ha. Break muna tayo ng 5 minutes, pwede? Nagiging robot na ako. Nagiging robot na ako. Wait lang ha.
Wala tayong natira. Makuha natin siya using
Hello, hello, hello.
ating average value. Ay ating average load, makuha natin siya using maximum
Hello.
load, maximum demand,
Robot pa ba ako
divided by
magsalita?
compound load factor.
Robot pa ba?
Hindi na po.
May sinasabit eh.
Okay, which is yun na rin.
Okay. So, sige, start na tayo.
At capacity factor natin, pwede natin
Okay
siya
na, okay
i-divide
na.
sa kanila.
Ayan na ulit.
Para
Okay.
makuha natin supply capacity.
So, shunt generator. So, ilagay agad kung ano yung circuit. Delivers. Again, delivers. That means it is in the output side of the generator. And this is your IL. And we have here the terminal voltage. Okay. Then we have the armature and shunt field resistance, which is 0.02 and 50 ohms. So to know what is the armature and what is the shunt field resistance, the shunt field resistance is
Yes, very good. Meron tayo.
always
50,750
have a big or higher
kilowatt.
value. It is always whole number.
Power station na
As
to
if, for
ay meron
example, 50, 60, 70, 80, 100, 200, like that. That is the value of RSH or shunt field resistance. While your armature or your series field resistance is always 0 point something. Okay? Like that. 0.02, 0.007, 0.05, like that. Okay? Then we have the iron loss, which is equals to 950 watts. When we say iron loss, that is PC, right? So, nasan ba si PC or si iron loss? Di ba nasa SPL yun? Forward, friction and windage loss plus PC plus FL. So, nandito siya. So, if it is given, then that is your SPL. Okay? Okay, so what is the overall efficiency? To get the overall efficiency, we need PO and PN. We can get PO, right? Because we have VT and IL. So PO is equals to VT times IL, and that will be 1.5 times 250. What is our PO or output power?
Yan yung mga lagi ko nakikita sa
Anong PO?
48,750 po.
Okay, that is our output power. Thank you po.
ating
Then we need to get the
So, in
input
case of
power.
future load,
Okay, ano nga po ang formula ng ating input power kapag shunt generator?
meron pa tayo naka-reserve
So we
na
have PO
50
plus,
na-supplyan natin.
eto, may kasama ba siyang resistances? Do we have any resistances aside from RA? None. So, that is IA squared RA plus, here we have VT squared over RSH plus SPL. Okay? So, do we have PO? Yes. Do we have IA? Wala. So, there's no IA. We have to get that. Okay, so to get IA,
Next naman natin,
from this circuit, we have IA is equals to ISH plus IL. So, what is ISH? VT over RSH. What is IL? PO over VT. So, paulit-ulit lang ano. Kaya masasaulo nyo siya. So, we have 250 over 50 plus PO is 48,750 over 250.
paano natin makuha si maximum demand?
So, parang ano lang to,
Given kasi nila yung versus
200 volts. Parang 195 plus 5, that is 200. Ampere pala, hindi volts. Ampere. So, that is our IA. So, now that we have the IA, we can now get the PN. Okay, so idiretso na daw natin, gaya dito. So, percent or overall efficiency is equals to
sum of all
48,750 divided by 48,750 plus 200 ampere squared times 0.02.
ano ating sum of all
plus, anong VT natin? 250 squared over 50 plus SPL natin, which is yung losses natin is 950 times 100. So, what is our overall efficiency? It is 94.20%.
Dito natin gagamitin itong diversity factor dito sa loops. Hindi natin siya pag-aada din para makuha yung ating total diversity factor. Meron tayo dito na overall system diversity factor na 1.4. Bali yun yung ating gagawin.
Tama ba?
Ano natin magiging maximum dito?
Same po ang sagot, ma'am.
Okay, so we have 94.20% overall efficiency. Okay? So, kung tayo ay nag-long shunt, short, long shunt, shunt, so short shunt naman tayo.
Meron tayo 10,000.
Pag short shunt, anong hitsura, isulat agad. Baka makalimutan pa.
Bali, meron na tayo una natin. Next naman natin hinanap ay yung connected load of each type. Ano, paano ba natin makuha yung connected load?
RA,
Meron tayo given na
IA,
factor. Pwede natin
ISH, RSH, RSE,
ay equals sa ating
we have L, then yung RSE, merong nagpo-flow na IL dyan. Ano? Equal naman siya sa ISE. So, ilalagay ko na lang na IL. Then we have your EG. Okay.
ano yung ating connected
Okay,
load?
so the winding of a short shunt compound generator has the following resistances. We have 0.7 ohm RA, RSH 0.5,
Divided by
RSE 0.15, RSH is 253 ohm.
meron yung magagawin natin ng
When the generator delivers a full load of 20 kilowatts and 500 volts, what is
or yung
that?
bawat maximum load
Naka-rating po. That means that is your PO and
Ano yung
VT.
connected load of each type?
So PO and VT,
consider natin yan ay
its total brush drop is 2 volts.
Pero,
Brush drop, that means VBC. And the sum of iron and friction losses is 800 watts.
kailangan natin i-consider
What is the full load efficiency? When we say full load efficiency,
gagamit tayo ng diversity factor na
that is the same as overall efficiency.
divided by maximum.
Okay? So, yun ang tinatanong. Then, to get the overall efficiency, we need PO and PIN, right? We already have PO, so we only need to get PIN.
Sa ating about
PO over PIN times
Hindi,
100.
para makuha natin yung
Okay.
maximum demand na natin. So, ang gagawin
So,
natin yung sum of all.
saan tayo magsisimula?
Sum of all.
Where do we start?
Sum of all.
Okay, let's start in
maximum
getting the
demand.
formula of the input power.
Para makuha yung
Okay.
maximum demand
So,
multiply by
based on the circuit, the input power is equals to PO plus IA squared RA. So, aside from RA, is there any resistances given that is in series with the armature? None. So, that is IA squared RA. Then we have VBCIA. What is that VBC? VBC is the voltage drop across the brushes or the total brush drop at the brushes, which is 2 volts. And to get the power, there you have to multiply it by IA. Why IA? Because, as I said, brushes were in series with the armature. Okay, so the current flowing at the brushes is armature current. Okay, so VBC times IA plus VX squared over RSH. What is that? Here. Okay, so why do we need to get VX? Because the terminal voltage here is not equal here anymore because we have here RSE, which is in series with the load. So you have to get the voltage across RSH. Okay, that's why we have Vx here. Vx is equals to Vt plus IL times RSE.
Meron tayong 2,400.
Okay? So, yan. Then, ISE squared times RSE. That is the power here. So, ISE, that is equivalent to IL. So, IL squared RSE plus SPL. Okay? So, ayan. Okay, so what to do next? So, if PO is there, so we don't have IA, we have RA, we have VBC, we don't have IA, we don't have VX, we have RSH, we don't have IL, we have RSE and SPL. So we have to get the currents first. IA, ISH, and IL. So we have to get that first. Okay, so ano yung pinakamadaling kuhanin? Si IL. Because, saan galing si IL? PO over VT, right? Excuse me. And that is 20,000 watts divided by 500 volts. Okay, so 20,000 divided by 500 is 40 amperes. And after that, what are we going to get? We can get ISH because ISH is equals to VX over VT. No, sorry. VX over RSH pala. We don't have VX pa. So we have to get VX first. VX is equals to VT plus IL times RSE. We have VT, we have IL, we have RSE. So VT is 500, IL is 40, and RSE is 0.15. So input that in your calculator and let's see if your VX is 506 volts. Is this correct? 506 volts?
Yes po, ma'am.
Okay, so now that we have Vx, we can now get ISH. ISH is equals to Vx over RSH, wherein Vx is 506 divided by 253. Our ISH is 2 ampere. So now that we have IL and ISH, we can now get IA. IA is using KCL at node A, IA is equals to ISH plus IL, right? So, ISH is 2, IL is 40. So, we have IA, which is 42 ampere. Okay, so we have Vx and IA now. We can now move to PA. Okay, so substitute all the given parameters. So we have 20,000, which is your PO. IA is 42 squared times RA na 0.7 plus VBC na 2 volts and IA is 42 ampere plus 506 squared over 253 plus 40 squared times 0.15 plus 800. Okay, so the input power is 23.3708 kilowatts or equal also to 23,370.8 watts. So we have now input power and output power. We can now get the overall efficiency. Overall efficiency is equal to 20,000 watts divided by 23.3708 kilowatts. So, i-times na lang sa 100 and our overall efficiency is equal to 85,000. Inaantok. 85.58%. Si ma'am, may mga sinasabi na sa sobrang bilis magsalita, iba na yung sinasabi. Okay, so 85.58%. So, nakapag-example na tayo ng long shunt, short shunt, at shunt generator. Naintindihan nyo naman. Okay, paulit-ulit lang siya. Very repetition. It's just that you have to know how to analyze the circuit. Okay, so that you will know how to get the input power per generator. Per generator yan. Okay, so what is the next everything? Ah, okay. So, ito naman.
Dito muna yung ating daily load.
So, dito,
Ano tayo daily load?
half load efficiency ang hinahanap.
lang natin.
Half load. Okay? So, a 200 kilowatts loaded station generator has a constant loss of 1,020 watts and shunt resistance of 10 ohms. If the efficiency at full load is 87%, calculate the efficiency of half load. Okay, so I will give you technique about this problem.
20, 6 a.m.
So,
Halimbawa 6 a.m. natin dito sa ating
when we have two conditions, okay, two conditions, that means, nasabi ko na to kanina, that means the first condition, in the first condition, you have to get something or some parameter or unknown parameter that you will use for the second condition. So you have to know what is that parameter that you need. Okay, so first is you have to
Next naman natin,
write all the given parameters. So we have PO and VT as always. Ano? Rating ng generator. So we have PO 200,000 watts. We have terminal voltage 200 volts. We have a constant loss of 1,020 constant loss. That means SPL na din siya. Okay? Then shunt field resistance of 110 ohms. Full load efficiency is 87%. Calculate the half load efficiency. Okay, so how to know what parameter will you get or what parameter is unknown. Okay, so if there is a full load efficiency and there is an output power that is given, that means you need to get the input power. Okay, so we have overall efficiency is equals to PO over PN times 100, right? So we have here PO and efficiency. That means we can now get the input power at full load.
Next one.
At full load.
4 p.m. to 8 p.m. daw ay 20.
So we have 200,000, which is your output power, divided by 0.87, which is your efficiency at full load. Then we will get an input power of 229.8851 kilowatts. Okay, so now that we get, or we have that input power, so write the formula in getting the input power. Okay, ano ba tong, ano na to? Circuit, shunt generator. Shunt generator, what is the kahitsurahan? This is your shunt. We have here RA, RSH. We have the load, ISH, IA, EG. Okay. So the input power of a shunt generator is PO plus IA squared RA plus VT squared over RSH plus SPL. So that's all. Okay. We have PN. We have PO. We can get IA. We don't have RA. We have VT, we have RSH, and we have SPL. So that means you need to get RA enable for you to get the half load efficiency for the next condition. Okay, so you can't move to the next step without getting that RA. Okay, you always have, or you always need an RA or the armature resistance. Okay, always. So if it is not given, then automatically you need to get that RA. Okay, so PN is 229.8851 kilowatts equals to 200 kilowatts plus yung ating IA. So, ano ba si IA? Paano natin kukuhanin? From this circuit, IA natin is IA plus ISH, right? Or in IL is PO over VT, ISH is VT over RSH. So we have 200,000 divided by 200 plus 200 divided by 10. Therefore, IA is equals to 1,001.8182. Okay, that is your IA. So we can move now to the equation. So IA is 1,001.8182 quantity squared times RA, which is the unknown. Then we have 200 squared divided by 110 plus SPL na 1,020. Okay? So please don't use shift solve. I need to see the equation of RA here. Okay? So anong gagawin nyo? This one, minus nyo to, minus din ito. Yan. Ang matitira is yung naka-minus dito sa kabilang side end, 1,001.8182 squared times RA. I-divide nyo both sides by 1,001.8182 squared, then you will get your RA. Okay? So what is your RA? 0.0284 ohm. Again, I need to see the equation of RA, okay? So, as I've said last week, shift solve is for checking only. Okay? So now that we have RA, we can now move to the second condition. So second condition, it says that half load efficiency. Okay, so when we say half load, that means half or divide by 2. Ano yung i-divide mo sa 2? Half load. The word itself, load. Ano ba yung nasa part ng load? Diba? IL and PO. Diba? Pero yung VT, that is constant ha. Hindi mo siya i-half load yung VT. It will remain VT. Okay? So, you will get the half load of the output power and the half load of the load current. Okay, that's all. Okay, so we have 200,000 watts divided by 2. That is 100 kilowatts. And your IL is, ano ba yung IL natin? From here, IL is 200,000 divided by 200. That means your IL is 1,000 ampere here in full load. How about in half load? So 1,000 divided by 2, that is 500 amperes. So we have now the half load of output power and the half load of load current. So we can now move on to efficiency at half load. So the efficiency at half load is PO at half load divided by PN at half load times 100. So we already have PO at half load. So we can now get the input power at half load. So that is PO at half load plus IA at half load squared times RA plus VT squared over RSH plus SPL. Okay. So, di ba constant to? Constant losses. Kaya hindi siya magbabago. Yan na yan. Ang nagbago lang is yung PO at IA. Saan po manggagaling si IA at half load? Di ba si IL at half load is 500. So, IA at half load is equals to IL at half load plus ISH. So, IL at half load is 500 and ISH is 200 divided by 110. So, IA at half load is equals to 501.8182 ampere. Okay? Times yung RA which is galing dun sa first condition. Magtataka kayo, bakit mami nang ginamit second condition na? Si resistance po is hindi siya nagbabago. Constant po si resistance. That's why, even though it's galing or it's from the first condition, it's just the same. We will use the same resistance. Plus 200 squared over 110 plus 1,020. Your half load efficiency is 92.30. Naintindihan?
Yes po, ma'am.
Bali, unang option natin, pwede natin siya makuha using
Okay, so ayan. Ito naman is ang kinukuha electrical efficiency. So ano nga sa electrical efficiency? That is PO over PG. So, feeling ko naman alam niyo na kung paano yung kuhanin. Ano, wait lang ha, si air break muna tayo.
meron tayo,
Si air break.
meron tayong 20 megawatts multiply by Meron tayong 25 megawatts. Yan yung ating magiging installed capacity. Nakuha ba? Ito yung ating tinatawag na power plant
Hello?
capacity. Yung ating power plant na to ay
Hi!
25 megawatts.
Hello po.
Okay, start na tayo ha para matapos na to.
Ito ay si coal-fired power plant. Bali ating coal-fired power plant na to ay may capacity na 25.
Saan na tayo?
So, pwede siya makapag-supply ng
Ito.
25.
Okay, so ito is
Plant capacity at
papaliwanag ko
saka
lang
yung
sa inyo yung about sa feeder resistance.
Sa tingin
Ano,
namin,
and then, kayo na yung mag-solve. Ano kasi, ito naman ay, ayan, ito na nga, sige na,
yung plant
paliwanag ko na.
factor.
So, a shunt generator supplies a load of 5,500 watts at 110 volts through a pair
Capacity na tayo, makukuha na natin si
through a pair of feeder conductors having a resistance of 0.02 ohm each. The armature shunt field resistance are 0.15 ohms and 50 ohms respectively. Find the EMF generated. So, may binigay na rating ng shunt generator which is 5,500 watts, which is your PO, and 110, which is your VT. Okay, so ano nga ba yung hitsura ng ating shunt generator? Di ba ganito yung shunt generator?
May average load ba tayo?
So this is for RSH. We have the load, we have the VT, we have here ISH, IL, we have IA, RA, EG. Yan. Okay. So sinabi dito, meron daw feeder conductors or pair of feeder conductors having a resistance of 0.02 ohm each. Pag sinabi pong feeder conductors, yan po ay resistance or feeder resistance. Ano, feeder resistance na nakasiris po sa load. Nakasiris sa load. Kaya po, ang nangyari sa ating circuit ay naging ganito na. Ano, so ito si load natin. And merong nakasiris na RF or yung feeder resistance natin. Okay. So, from this shunt generator, naging ganito na siya. Ano yung hitsura na niya ngayon? May familiar ba siya? Anong type of generator na to? Itong hitsura na to? Hello? Shunt generator ba or short shunt generator?
Short shunt po.
Okay, so parang naging short shunt generator na siya kasi 'di ba yung RSE natin sa short shunt generator nandito? So parang naging short shunt generator na siya and to get EG, meron ding ang tawag dito, iba na rin yung pagkuha ng ISH at nang may VX na siya. Ano? So parang ganun lang din talaga siya. Okay? So, we have PO, VT, RA, RSH, and then yung feeder, sabi ay pair. And 0.02 ohm each. That's why it's naka times 2. So, 0.02 times 2 is 0.04 ohms. Okay, so that is your RF or feeder resistance. Okay. So, to get what? To get ISH. So, hindi na equal yung VT dito sa voltage dito kasi meron ng nakaseries na feeder resistance sa taas. That's why kumuha po ng VX. To. VX is voltage dito plus voltage dito. So, that is VT plus current dun sa feeder at saka resistance ng feeder. So, yung current sa feeder, what is that? Diba IL din yan? Equal din siya. So, this will be IL times RF. So, ganun lang din siya. Okay, yung pagkuha ng VX kapag ka naka-short shunt generator tayo. And, yung ISH, pagkuha ng ISH, that is VX over RSH na. But the rest is just the same. Okay? So, yung pagkuha ng EG dito, napansin ko lang is, dito siya KVL sa inner loop. Nag-KVL siya dito. Naging EG, minus,
Meron tayong
di ba
12
ito, ang
megawatts
voltage dito
divided
is
by
Vx. That's why it's minus Vx minus Ia Ra equal to 0. That's why it's Eg is equals to Vx plus Ia Ra. But, yung atin na outer loop, let's try to um,
Yes, very good. Meron tayong
get the
0.44,
equation sa outer loop. That will be Eg minus Ia Ra
48%.
minus IL Rf minus Vt equal to 0.
Nakuha ba?
And that will be Eg equals to Ia Ra minus IL Rf
Next natin ay yung ating release
plus na siya,
generated
plus
per
Vt.
annum.
Ayan. So, as you can see, si IL Rf plus Vt, that is equal to Vx. So, maalin dito sa dalawa, pwede nyong
Ito naman
gamitin.
tayong option to
Depende sa inyo
apply
kung saan
our
nyo
release
gustong
generated per annum.
mag-KVL. Ano,
So,
sa
una
outer
yung
loop
ating
man or sa inner
kailangan is
loop,
load
same
curve.
po ng makukuha na
Since ito ay static
value.
naman, kukuha natin yan.
Okay? Same lang po ng makukuha na value.
And yung
Okay?
isa
So,
ay through the
please
use
try to
of,
solve this
since
one.
ito ay unit
Ha?
generated per annum, ano ba
Parang
formula natin
yung
dito?
shunt generator,
Meron tayong
nagkaroon
formula
po
na
ng feeder
average
conductors,
load
naging mukha siyang short shunt
multiplied
generator.
by
Again, ang
number of
feeder
hours in a
conductors po
DC motor
ay
2007.
in series
So, makukuha natin
with
yung ating unit
load.
generated per annum using
In series with
yung
the
ating
load.
average load. Meron tayong 12 megawatts.
Di ba yung brush contact
Multiplied by
resistance is in
87.
series with the armature, tama? Ito naman, in series with the load. Okay, so please try to solve this, ha? Okay, next. Ito naman is electrical efficiency. So when we say
Meron tayong
electrical efficiency from the power
5,750
stages,
megawatt
we have here Pin, PG, PO. We have here SPL. We have here PCU. So if it is electrical, it's in this part. That's why it's PO over PG times 100. So we need PO and PG. Okay? So the field current of 180 kilowatts, 250 volts DC shunt generator is 6 ampere when running full load at rated terminal voltage. If the combined armature and brush resistance is 0.02 ohm, solve for the electrical efficiency of the generator. So shunt generator daw,
8760 times yung ating H1 plus H2. Anong ating H1? Meron tayong 20 megawatts. Plus 4 megawatts.
ayan. So ito yung ating shunt generator. Ang sabi, the field current of a blah 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 generator is 6 ampere. Sabi ay field current. Pag sinabi pong field current, ano yun? Series field or shunt field? So, titingnan nyo po doon sa value. Ang value po ay mababa. 6 ampere lamang. That means it is a shunt field current. Okay? Di ba yung shunt field resistance natin malaki lagi? Mga 50, 60, 100, 120, 220, and so on. That means your ISH is mababa. Ano? Saan po galing yon? Di ba yung ating Ohm's law is I is equal to V over R? So they are inversely proportional. So when your R is low, your current is high, and when your resistance is very high or high, then your current is low. So if your resistance or RSH is high, let's say 200 ohms, then your current is low. Okay? So that means if ang binigay sa inyo ay field current and it has low value, then it is a shunt field current. Then there is
So,
Given
paano
po ang
natin malalaman
rating,
bakit pwede?
ano rating ng generator? So we have 180 kilowatts, which is your output power.
Alin
We
ba
have
yung ating may
250 volts,
highest
which is
point
your terminal
sa ating
voltage.
voltage?
And
Load choice.
sabi meron daw combined armature and brush resistance, which is 0.02 ohm. What is the electrical
Kaya
efficiency?
itong ating 20
Okay,
megawatts, siya yung ating magiging maximum.
so we have
Ano naman yung
PO,
ating
right?
magiging load factor?
So we need to get
Given.
EG. PG is EG times IA. Do we have EG? Wala. Do we have IA? None. Okay, so we have to get that. So,
0.6 or 60%.
alin ang uunahin natin kuhanin? Which one? EG or IA?
Okay.
Hello?
So, in the last one, meron tayong
Who's gonna
tinatawag na
be the
utilization
first
factor.
honor?
Same po ba siya ng ating use factor? Hindi
Okay,
po.
so
IA po.
Yung utilization
CIA,
factor natin ng
that's
formula natin
correct,
kaya ano,
because
ang ating plant
to get
capacity,
EG,
capacity
you
factor
need
equals sa
IA.
ating
So we have to get
average
IA
load divided
first.
by plant capacity.
Okay, so to get
Ang ating
IA,
plant utilization
IA is
factor
equals to IL plus ISH. We have ISH, but we don't have IL. Where can we get IL? IL is equals to PO over VT. We have PO, which is 180,000 watts, and we have VT, which is 250 volts.
plant capacity.
So that we will get an
So, yung
IL of
ating formula, ano ang ating
720
magiging
ampere.
utilization factor?
So to get IA, we
Ano
have
ating maximum
720
demand?
plus
20
6
megawatts.
ampere, which is
Ano ating
756
magiging
ampere.
plant capacity?
So now that we have IA, we can now get EG.
Ano ating magiging
generated
final natin
voltage.
utilization factor?
So from this circuit, ano yung EG natin?
Meron tayong
EG
papalit gas
minus
dahil 0.8
IARA
or 80%.
minus
So,
VT
maaari
equal
dito
to 0. So that we can have now EG is equals to VT plus IARA. VT is 250, IA is 726, R8 is 0.02. Actually, that is R8 plus RBC. Kasi sabi ay armature and brush resistance. Okay? So, yan, 0.02. Then we will get EG, which is 264.50 volts. So now that we have IA and EG, we can now get PG, or the generated power, which is EG times IA. EG is 264.52 times 756. That is equals to 190.041 kilowatts. Okay, so now that we have PO and PG, we can now get the electrical efficiency,
So, goods na tayo doon.
which is 184
So, next naman natin ay yung
divided
pag-select
by
natin ng generating units. So, yung size,
192.041
at hindi lang bilang yung
kilowatts times
ating
100.
generating.
So, ang makukuha po natin
So, ang ating
electrical
gawin natin power
efficiency
station
is
na natin natin ang pagbabago yung ating mga loads. Makikita niyo yung sa regulation curve.
So, do you have any question?
Mabago siya, varying siya from time to
So,
time.
mag-step by step kayo ha, kung sino uunahin kumain,
Or, let's say,
kung ano ng mga
will not be an
kailangan.
economical
But first,
composition.
you have to draw the circuit,
Sabi, kasi sabihin
write
natin
all the given parameters,
okay, yung naging
and
maximum
ano,
naman ay 100
then
megawatts.
step by step.
Ano na
Okay.
ito? Yung ating maximum demand system. Pero during
Next.
the whole day, meron tayong mga loads na
A long shot compound generator has the following parameters. We have RA, RSC, RSH, and this machine supplies power aggregated load DC
hindi siya pare-pareho.
load of 10 kilowatts. So what is that DC load? DC load of 10 kilowatts, that means that is your output power. Kasi nasa load diba? Ang nasa load ay POVTIL, diba?
To use our alternators.
So ito yung mga given natin. Then, at this load, the armature generates 246 volts. So voltage, then generator. That means that is the generated voltage, which is 246 volts. Ano daw ang terminal voltage?
20%.
Okay, so shunt or long shunt. Long shunt.
So yun, ang target kasi natin ay magamit. Then half load lang siya, pababa. Hindi yan.
Hello po.
Napakamahal na efficiency. So kaya minsan, ang ginagawa
Okay.
natin dito
Meron
ay
po bang tao?
nagdadagdag tayo, hindi natin pinakonsider ang single unit or power
Pero
plant.
bukas po ang gate.
Unless yung
Hello po. Sorry, tumawag ang delivery delivery rider. Okay, so ayan. So ano nga ba yung long shunt? So long shunt is ito po yung hitsura niya. Ano? Again, sa examination po ninyo, there is no drawing of a circuit. No circuit. There's no circuit drawn. So you have to draw it yourself. Okay. RA, AG, RSE, RSH, VT, ISH, IA, ISE, IF. Okay. So ito yung ating long shunt compound generator. So from this, let's get the equation for EG. Okay. So, di ba EG minus IA times RA plus RSE. Kasi yun yung mga nadaanan ni IA, di ba? Si RA at RSE. Minus VT equals to 0. So, equate natin kay EG. Okay, equate kay EG, then we will get EG is equals to IA, RA plus RSE plus VT. So, how to get IA? IA po is equals to ISH plus IL, wherein ISH is equals to VT over RSH, and IL is from PO over VT. So, lagay niyo lang dito, ano? So, after that, ito na yung pinaka-formula natin. Let's put or let's substitute all the given parameters. So, we have an EG of 246. We don't have VT. That is the unknown. Then we have RSH 120. We have PO 10,000 watts. We have VT. Wala pala. Then RA and RSE plus VT. So, I want you to simplify this equation. I-equate nyo kay VT because VT is the unknown parameter. So, please simplify. Don't use shift solve. Please simplify it. Okay? So, pagka ganito ang inyong sagot, mali yun. Okay? So, you have to simplify it. Again, shift solve is only for checking. Okay. So, the answer is VT, which is equals to 239.4360. So, pwede kayo ditong mag-multiply both sides ng VT or multiply ng 1 over VT. Kayong bahala kung saan kayo mas naaalwanan. Kung saan mas madali. So, please simplify. Okay? Okay, next example. Wala na pala. Okay, so this is the last topic in DC generator. Maximum efficiency. Okay, so when we say maximum efficiency of the generator, the principle is that the variable loss is equals to constant losses. Okay, and when the problem is about the maximum efficiency, you have to get first the maximum armature current or IA max. Dito kayo lagi magsisimula. Okay. Then the formula is square root of VT squared over RSH plus SPL divided by RA. And all resistances connected near armature, you will add it here. Add nyo lang. Let's say may RBC na binigay. Add nyo lang dyan. Let's say naka-long shunt kayo. Pag long shunt ang generator, di ba may RA dito, may RS dito. So, isasama mo siya dito. So, that means you will add RSE. Okay,
Yan yung
again,
ating
it depends
generator
on what type
unit
of
number 1.
generator you have. Okay,
Yung unit 2 naman
so after
natin,
getting the I
from
max,
this point
get the
up to this
IL
point,
max. Why?
ito naman yung ating
Because,
unit 2.
okay, so IL max is equals to IA max minus ISH. ISH is constant because saan galing siya? VT over RSH, di ba? So, it's just the same
Ay,
as
meron tayo?
like in the normal situation.
250.
So, PO max
All in all, meron tayo ng stored capacity
is equals to VT times IL max. Why do you need PO max? Because to get the percentage or the
Pero yung
maximum
ating kasing
efficiency, we need PO
maximum
max
dito
divided
ay
by
nasa
PI
500.
max
So, meron
times
tayong
100. So to get PO max,
150 kilowatts.
you need VT times IL max. And to get PI max or input or maximum input power, you need PO max plus 2CL or 2VL. Bakit po ganun?
Sir, bakit hindi po tayo
Di
gumamit
ba
ng
kapag ka sa normal
500
ano
kilowatt? Sabi ko nga kanina,
situation,
hindi siya.
so si PIN ay PO plus VL plus CL. VL is the variable loss and CL is the constant loss. But here, VL and CL are equal. That's why it's going to be 2VL or 2CL. So, kung ano man ang gusto nyo dyan gamitin, it's just the same. But, we always use 2CL. This one, the red one. Ano, yan ang lagi namin ginagamit. Wherein CL is equal to VT squared over RSH plus SPL. Okay, that means PI max is equals to PO max plus 2 times VT squared over RSH plus SPL. Okay, so that is how you get the maximum input power. Then you can also use PG max plus SPL, where PG max is equals to EG max times IA max. Okay, so ayan po yung mga formula kay maximum efficiency. So let's have an example. Okay, yung number 1, sasagutan ko, and then yung number 2 is papaubaya ko na sa inyo. There is a final answer here. Palabasin nyo na lang. No? Okay, so the long shunt compound generator delivers 65 kilowatts, 250 volts, 1,500 RPM. RA is 0.030 ohm, RSE 0.007, RSH 50 ohm, SPL is 1,020 watts. Calculate the maximum efficiency and the power output at which it occurs. So, maximum efficiency at saka maximum output power. Okay? So, first is ilagay ang circuit, long shunt daw. Laki ng drawing. RA, RSE, RSH. We have here VT. Paulit-ulit na, no? Sa ulo nyo na to. Kakapaulit-ulit ko dito. Yan. Okay. So, sabi, meron daw, ang generator daw ay nagde-deliver sa load ng rating na ito. That means that is your PO and VT. So, PO mo 65 kilowatts. Then, VT is 250 volts. Then, yung RA daw natin is 0.030 ohms. CRSE daw natin is 0.007 ohm. Then, we have an RSH of 50 ohm. May SPL daw na 1,020 watts. Ano daw ang maximum efficiency? series si RA kay RSE. So we have to include that here. So we have 250 squared over RSH na 50 plus SPL na 1,020 divided by RA natin is 0.030 plus 0.007. What is our IA max?
12 midnight. Tingnan natin at 12 midnight. So, meron tayong load na 100 kilowatts. Kilowatts. Ayun pa. May time. 12 midnight, meron tayong 100 kilowatts. So, based dito sa ating 100 kilowatts, ang kailangan lang natin i-operate ay si unit 1, right? Pwede natin siya i-operate.
247 point, ano nga to?
Pag na-fail natin, pwede gamitin si unit 1. So, 150 kilowatts.
Nasisira na yung pen ko, nagputol-putol. Ano sagot din eh, nandun pagka kayo?
247.692049 po.
Okay, so 0 na lang, 20. Thank you po. And now, ano ba yung kailangan natin? Diba, maximum efficiency is equals to PO max over PN max. To get PO max,
at this point,
that is DT times IL max. So that means we need to get IL max. No? So si IL max po ay IA max minus ISH, tama? So that means 247.6920 minus ISH. Anong ISH natin?
Mag-adjust tayo ng 4, 6, 5,
ISH is VT over RSH. So that is 250 250 over 50. So ano magiging IL max natin?
Power unit para ready na natin siyang i-run. So, 12 midnight to
242, tama ba?
ating unit number 1 ay
Yes po.
Okay, so minus 5 lang naman eh. 242 minus 6, 242.6920. Ano,
12
thank
midnight
you.
to 7
So,
a.m.
anong
unit
PO
1.
max
Siya
natin?
lang yung ating in-operation. Only. Siya lang yung nag-operate natin from 12 midnight to 7.
Yung sakto ha.
Then around 7 a.m., mag-start tayo ng 7 a.m. up to, tingnan natin.
Ito ba yung 60,000 something?
Tumaas yung ating load starting from 7 a.m.
60,673
po.
60,673 watts. Okay, thank you.
Below 300
Then,
kilowatts
we need to
siya.
get PN max naman.
Below 300
So, PN
kilowatts yung
max,
ating naging load curve
that
dito.
is PO max
So, dito
plus
natin magtatakbo ng another.
2CL, wherein CL is equals to VT squared over RSH plus SPL, tama?
Unit number 2.
So,
From 7
PN
a.m.
max
up to
is equals to 60,673 plus 2 times 250 squared over 50 plus an SPL, 1,020. Yan. Anong PN
7
max
a.m.
natin?
to 12 noon. Start na natin. I-start na natin si unit 2. Yung operation na siya.
Anong PN max?
So, bukod sa ating unit 2, yung ating unit 1 ay
Parang
natakbo.
65,213 po.
Yan. So, that is correct. Thank you. Yes po.
Combination ng ating unit 1.
May nagsabi ng sagot ano?
Both
May nag-chat.
units 1 and 2
So, anong ating maximum
ay in operation.
efficiency?
Nakuha ba yun? Nakakasunod ba lahat?
93.0381% po.
Okay. So, 0.4 na lang. Ano? 2 decimal places lang pagka
At this point, dito
efficiency.
sa
So,
ating 12 bigla ulit siyang
93.04%.
bumaba.
Thank you po. That is
Bumaba siya
correct.
ng 150
So, ano pa nga hinahanap?
kilowatts.
PO max. So, lalagyan nyo ng box, ha?
Yan, bumaba
Huwag
siya.
kakalimutan lagyan ng box kung ano yung mga hinihingi. Kasi yung iba, nagpo-focus sa isa lang na hinihingi, hindi na nagbabox yung ibang sagot. So, that's it for now. Okay, so tapos na tayo po ng DC generator. I hope may naintindihan kayo. So, yun pong in-upload ko na PDF wherein nandun yung mga example na ito or example problems. Please answer it. Please practice solving. Ito din naman yun. Ang gusto ko lang is answer it with your own solution, with your own understanding, and without looking at my solution. Okay, please. So if you want to screenshot this, please do, because I think I will not be able to upload this because there is not enough everything, not enough MB and storage and kinemerot. So please screenshot. 1, 2, 3, 4, 5. 5, 4, 3, 2. 1, 2, 3, 4, 5.
2 p.m. 5 p.m.
2, 3, 4, 5.
Ay tumaas yung ating load. Up to 300 kilos. So pwede ulit natin i-start ulit yung ating unit 2 is started on. That is the operation. Bale, parehas ulit na ang ating unit 1 at saka sa unit 2. Ay, operation.
So ito yung isang problem, sagutan ninyo. May final answer naman yan.
Then,
okay, so if you don't have any question,
tumasa nga siya ng
violent
300
reaction,
kilowatts at this time. Before that, pwede na natin start.
pwede na po kayo. So thank you for listening.